In the last video, we looked at how we can use Herman's single factor test to determine whether a dataset suffers from common method bias issue or not. In this video, we will look at how we can use the common latent factor technique to determine whether a dataset suffers from common method bias issue. In order to determine this, we first develop a confirmatory factor model as specified in the diagram, and then we run the analysis. We make sure that the model fit indices are above and below the threshold values and there is no error associated with the convergence of the model. Once we determine that the data fits the model, next we go and look at the standardized regression weights. We copy these standardized regression weights and save it in an Excel file. Next we add a common latent factor to the confirmatory model that we just worked upon. In this model, we link the common latent factor to each of the observed variables and also constrain the path to be equal. In addition, we also make sure that the variance of the common latent factor is constrained to 1. This is done in order to make the model identifiable. Once the model is specified, we go ahead and we calculate the estimates. We will get an error message which will require us to specify covariance between the 3 latent factors and the common latent factor. However, we will just proceed with the analysis. If we go and look at the results, we find that there is an error of covariance matrix being not positive definite. So the results are not accurate and we need to put some constraints in order to make the model identifiable. So we go ahead and constrain the covariance between tangibility and reliability factor to be 0, and we again run the analysis. If we now look at the convergence of the model, we find that the model converges and also the model fit indices are above and below the threshold values. So the next step is to look at the standardized regression weights of this constrained model and save these regression weights in an Excel file. In this Excel file, we have saved the standardized loadings with common latent factor and the standardized loadings without common latent factor. In order to conclude that the dataset does not suffer from the common method bias issue, we want the difference between these two observations to be less than 0.2. So here we can see that the absolute difference between the standardized loadings without a common latent factor and the standardized loadings with a common latent factor for all the observed variables is less than 0.2. Therefore, we can safely conclude that the data does not suffer from common method bias issue using the common latent factor approach.